Hello and welcome to the launch of SimCenter Femap 2022. The theme of this year's release is collaboration. My name is Mark Sherman. I'm the Director of Software Development for SimCenter Femap here at Siemens Digital Industries Software. I'm joined by Andy Haynes, the Application Engineering Manager for SimCenter Femap. Together we'll walk you through what's new in our 2022 release in just a few minutes. But before we do that, I'd like to take a moment to talk about digital transformation. We are deeply committed to helping companies accelerate their digital transformation. As you can see here, we continue to expand the Siemens Digital Industries Software product portfolio with huge investments to combine the real world and the virtual world. The result of that investment is Accelerator, a catalyst for the digital enterprise. Accelerator is our comprehensive, integrated portfolio of software, services, and an application development platform. The portfolio accelerates the transformation of businesses into digital enterprises and unlocks a powerful industrial network effect. These are essential requirements to leverage complexity as a competitive advantage, no matter the industry or company. SimCenter, a key part of Accelerator, is a flexible, open, and scalable portfolio of the best predictive simulation and test applications that support customers at every step in their digital journey. The SimCenter portfolio addresses the full breadth of methodologies for engineering, covering system, mechanical, and CFD simulation, electromagnetics, electronics cooling, and physical testing. And a critical part of that SimCenter portfolio is SimCenter Femap, our high-performance finite element modeling and analysis solution. SimCenter Femap is the market-leading pre- and post-processor for engineering analysis. It's a mesh-centric finite element modeling and analysis software that operates independently of the CAD system. Advanced workflows in SimCenter Femap allow users to model components, assemblies, and systems to determine a model's response when subjected to real-world conditions. SimCenter Femap works in combination with a wide variety of commercially available FEA solvers. Additionally, SimCenter Femap provides powerful data-driven and graphical results visualization and evaluation. Combined with the SimCenter Nastran solver, this delivers a comprehensive solution for engineering simulation. I'd like to take a moment to share a customer story with you that demonstrates the power of SimCenter Femap in action. Here's a Siemens customer and a project that you're probably very familiar with, NASA and the NASA James Webb Space Telescope. More than 20 years ago, NASA set out to build the most powerful telescope ever put into space. James Webb would require unprecedented engineering and optical design. SimCenter Femap and Siemens software played a critical role in making that possible. Designing, testing, building, and assembling James Webb was a team effort that took place across 3 continents. The telescope's instruments were tested using a variety of CAE solvers for modal, thermal distortion, and structural analysis. SimCenter Femap helped bring these efforts together as NASA's go-to application for pre- and post-processing. Using Femap, NASA conducted simulations to minimize thermal distortion in the extreme heat and cold of normal operations, as well as ensure structural integrity during launch. James Webb was launched on December 25, 2021 by NASA, in collaboration with the European Space Agency and the Canadian Space Agency. And now that it has reached its final destination, James Webb is a gold-plated 21-foot mirror that is meticulously engineered to observe objects farther out in space than any telescope before. At 22 meters by 12 meters, James Webb is very large, almost as large as a Boeing 737 jet. On March 16th, NASA engineers shared the first test image taken by James Webb after fully focusing the $10 billion observatory on a distant star. To get to this stage, all of Webb's mirrors had to be aligned within tiny fractions of the width of a human hair. We not only see the star and the spikes from the star's diffraction, but you can also see other stars in the field that are tightly focused, and all other sorts of interesting structures in the background. If you look closely, you can see entire galaxies. As it explores the reaches of deep space, James Webb will have the opportunity to study distant stars, exoplanets, and find answers to some of the most important scientific questions of all time. Now, let's bring it back to Earth. For more than 30 years, SimCenter Femap has provided CAE software users with the tools required to accurately model and simulate structural, dynamic, and thermal performance of complex engineered systems. We're continuing that long-standing tradition with SimCenter Femap 2022. This release delivers several new features and enhancements to improve modeling efficiency and collaboration. Our 2022 release includes numerous new features and enhancements. Today we're going to focus on 5 key areas of our 2022 release: cloud collaboration, hex-dominant meshing, laminate improvements, new simulation entities, and solver support. If you have any questions as we explore these features, feel free to post a question in the live chat. We'll get to them now, or we'll get to them at the end of this session during the Q&A. In SimCenter Femap 2022, you can instantly, securely, and easily collaborate with colleagues, partners, and customers with Siemens' next-generation cloud-based collaborative solution, Accelerator Share. Complex problems require effective collaboration. Cloud-based software can remove hurdles standing in the way of finding a solution. Accelerator Share and SimCenter Femap offer a wide range of collaborative features. Share's rich set of capabilities addresses your cloud collaboration needs. It provides teams with secure central storage with optional data management tools. It enables the ad hoc collaboration with internal and external stakeholders thanks to easy email-based address, project, and file sharing. Accelerator Share is the first cloud component of our new Accelerator as a Service, or ZaaS, subscriptions. What are ZaaS subscriptions? Siemens and its customers are facilitating digital transformation with Accelerator as a Service. We're expanding Accelerator to include the transformative capabilities provided by the cloud, further enhancing collaboration and cross-domain capabilities with new functionality being added over time. SimCenter Femap ZaaS brings you everything that you know and love about SimCenter Femap with the benefits of cloud services through a ZaaS subscription option, making Accelerator more accessible, flexible, and scalable. Just to be clear, Accelerator Share is not a replacement of our standalone SimCenter Femap product. It's simply an opportunity to take advantage of our new cloud-based collaboration solution through a flexible subscription.
Okay, so the first thing we're going to do is we're going to talk about Femap's integration with Accelerator Share. Now, the way that Femap talks to Accelerator Share is through the Siemens connector, which is just something that is going to appear down here in the tray. At any time, you can see kind of the most recent things you did between Femap and Accelerator Share down here in this connector dialog box. So someone has put some geometry that they want analyzed out on the cloud for me to do some analysis on. So I'm just going to go to File, Share, Import Geometry. So I'm just going to pick my piece of geometry from the Accelerator Share interface. I'm just going to say Import, then it just imports just like any other piece of geometry in the Femap. I can see it's the internal portions of a wing. Okay, so let's just move forward in Femap. I've done my modeling, meshing. I've put properties, materials, etc. So this model is basically ready to run, but I need to send it to somebody else to examine. So they're going to tell me where I'm going to put my loads and boundary conditions. So the way I'm going to do this is I'm going to save this to a projects folder using the connector. So I'm going to do File, Save As, and I'm just going to come up to my connector, projects. I'm going to find my internal wing structure project, and I'll just give it a name. I'll just call it internal, and then say save. And now as it's saving, I'm going to get this checkout will be available after this model is uploaded and synchronized to the Accelerator Share application. I just say OK. And then what I can do is I can come check out my connector. And you can see when it's got this little circle, that basically means it's in process. And as soon as it gets up there, it's going to turn into a green checkbox. For the time being, I'm just going to close my 2 models. I'll just go check my connector again. See, did it get fully synced up? It sure did. Great. So now, to get it back down from Accelerator Share, what I'm going to do is I'm going to go to File, Share, Open. And I'm going to pick my model file, again, via the Accelerator Share UI. It's going to say Open. It's going to open in here. You can see down at the bottom, it's going to tell me that the ModFem has been checked out successfully, which is great. Hopefully, they've put my loads and boundary conditions on here. I'll just check. Oh, yep, there are my constraints. And because this is a modal analysis, no need for loads. So we're just going to run our analysis. So what's going to happen here is I have some options for which files we want to get synced back up with Accelerator Share, and I can choose those with select software domains. I have them all checked for all of these different products, all these different file types, and I even have this one down here at the bottom, unclassified, turned on. So it's going to grab anything that is stored to our project directory that we're using with connector. So I'm just going to say OK. OK here. My results have been loaded in. We're going to take a look at them. All right. Look good. It's going to try to make it a little bit easier to see for us. And now what I can do is I can save this as a JT file. So I'm going to go to File, Picture, Save JT. I'm just going to give it a name. This is the first mode, so I'm just going to call it Mode 1. And I'm going to have some options I can choose for my JT file. Whether I want standard output or multi-result output, I'm just going to use standard output just so we just get this one output set and one output vector in our JT file. So I'm just going to say OK. And as soon as this is created, because I saved this to the project directory with connector, you can see that it's going to get uploaded here. Yep, there it is. But again, all of my log files and monitor files, etc., all my files from the Nastran run have automatically been synced up with the Accelerator Share as well. So I'm just going to go to this View Online. It's going to ask me to sign in. So it just needs to know that I'm signing in again. And then once I'm up here, the nice part about having a JT file up here is that it's going to be with the rest of the files from my project. And I can just go to it, and you can see that we have this little icon for a markup 3D. I can now click here, and I can actually now look at my results of this model via the Accelerator Share interface without having to take up a license of Femap, open a license of Femap. I don't even need Femap installed on my machine. I can basically just use this JT file to make some decisions about this particular model. Mark, back to you.
SimCenter Femap 2022 eliminates the need for extensive geometry cleanup and manipulation that's typically required to create a fully connected hex mesh. With the introduction of automated hex-dominant meshing, you have a set of interactive meshing tools to streamline the process of creating a high-quality mesh. Unlike legacy geometry splitting, hex-dominant meshing of solid geometry in Femap requires little to no simplification or subdivision into smaller and simpler regions. This is a capability that has been long desired by the FEA community. We collaborated with other teams across the SimCenter portfolio to deliver this exciting technology for the first time.
So when we're talking about the new hex-dominant meshing within Femap, it's a slightly different workflow than we had before. Typically, if you were going to hex mesh this, you would have used mesh control, size and solid, chosen hex meshing, and then done mesh geometry hex mesh solids. But what we're going to do instead is we're going to use our new command, which is just simply mesh hex mesh bodies. So in here, you're going to set a target element size, which is not a rigid element size on the curves, but instead just kind of a target size for the elements in the entire mesh that it's creating. There's some mesh associativity options, so either all geometry, required geometry only, or if you want to make sure that certain surfaces or certain curves get an associated mesh, you can do that as well. And then there's also some options for whether you want mid-side nodes on all elements or all but the brick elements that it's going to create. So I'm just going to click OK. And the meshing process has started. Now, typically, you would have had to subdivide a body like this into probably 30 to 40 pieces, and it would not have been easy. It's obviously splitting up the geometry is somewhat tedious. But with this new technology, all you have to do is basically use that one command, and it's just going to create as many hex, wedge, pyramid, and tetrahedral elements as it needs in order to generate the mesh. So now you can see that we have our mesh. Just going to turn off our geometry here. And you can see down here at the bottom, the mesh is 95% hex elements by volume. So that's So that's just absolutely terrific, and I didn't have to do a thing to this geometry in order for that to happen. Now, one other thing I'm going to do here is, let's just say you want to do some mesh refinement of these hex elements. We also have a newer command, which is mesh editing, mapped hex refine, and I'm just going to pick this top level, choose those, just make sure I got the right ones, yep, say OK, and then you're going to see that we're going to get a refined hex mesh that transitions back to the rest of the original mesh. Mark, back to you.
Engineers use composite materials to make product designs stronger and lighter. SimCenter Femap 2022 adds enhanced functionality that streamlines the creation and editing of complex layups. The Layup Manager now offers a user-friendly grid, much like Microsoft Excel, making it easier to create and edit layups. Data reuse is now encouraged with standard reference plies and with the ability to reuse existing layups within other layups. A new multi-layup editor has been added that allows multiple layups to be viewed side by side to assist in adding, deleting, and inserting plies, and assigning global ply IDs. These new additions are all connected, making it easier to effect bulk changes across multiple layups.
Okay, so the first thing we're going to do when we talk about laminate improvements is the model layup menu has been replaced with the model laminates menu, with layup being an option, ply material manager, global ply manager, and multi layup editor as now options. So the first thing we're going to do is just we're going to go into a layup. Now you can basically use the layups like you did before, where when you have ply type, you basically just choose a material from the drop down. But the nice part that you can do is you can now type directly in the cells themselves. So I'm just going to kind of set up a default ply here, and I can just right click and say, hey, set this as the default row. So now when I add, I'm just going to add about 4 in here. It's just basically going to use the same material, the same thickness, but I'm just going to change some angles here. Just some orientation angles. And again, I'm doing this right within the cell, which is something you just couldn't do before. And I'm just going to save this one as for use later. Oops. It's going to say OK. And now what I can do is instead of just making a ply, I can now actually reference that layup instead. So I'm just going to choose the layup, and I'm going to select which layup I want. That new one I made was just number 8 there. So now you can see that it's in there. I'm going to add a ply, and another thing you can do now is use a ply material, which is going to have the consistent material and thickness value for you. And now I'm just going to add one more ply here, and I'm going to add a layup, but I'm going to add it in a symmetric stack up. So I'm just going to choose my layup again, and now you can see that it put those plies in here in opposite stack up order. So we could then use that for, to update any of the elements that we have currently in our model. One of the other things that we can do, though, is we can come here to this, and we can go to Model. I'm actually going to use Modify, Edit, Layup, and I'm going to pick number 4 here. And you're going to see that I have quite a few plies in this particular model. So what I'm going to do is I'm going to come down here, I'm going to select them all, and I'm going to convert these to ply materials. Okay? So if it matches a ply material that we already have specified, it's going to just automatically assign that to that ply. It's going to make it a ply material instead. Again, this is good for consistency's sake. And if I have another one, I'm going to do that. And you can see all 74 of these plies actually corresponded directly to a ply material that already existed in the model. So it's just, again, just for consistency's sake and bringing models forward into the latest version of Femap that now offers the ply material is going to be very helpful. One other thing that we're going to talk about is we're going to use the model laminates multi-layup editor. And I'm just going to pick a few of these. I'm just going to pick my wing skins. It's going to say OK. And I'm just going to set a global ply with this. So I can basically just pick a row and then apply a global ply. And I'm just going to say mid ply for skins. And then I'm just going to say OK. And now that's a global ply that can be used on all three of those layups that I selected with the multi-layup editor. Mark?
New simulation entities in SimCenter Femap 2022 help improve representation of real-world conditions when simulating assemblies with moving parts. Kinematic joints have been added as simulation entities, providing support for advanced simulation methods such as flexible body dynamics. To accelerate the process of creating kinematic joints, joint connections have been added as a new, unique entity type, allowing users to establish how a kinematic joint will be connected to geometric entities or an existing mesh. Femap now has expanded support for kinematic analysis of mechanical systems with the addition of flexible slider simulation entities. Flexible sliders allow analysts to accurately simulate the deformation of curvilinear tracks as assembly components move along them.
Okay, so when we're talking about simulation entities, the first thing we're going to talk about is kinematic joints. So I'm just going to open up the simulation entities of the branch here, right mouse click and say I want to make a new kinematic joint. Now, when you're using kinematic joints, you actually need nodes defined at the place where the joint's going to occur. But since we have geometry, which we do in this model, we're going to make a kinematic connection instead. This can be a little easier, and it can also do some things automatically for you. So what we're going to do here is we're going to actually make a universal joint using surfaces for both the reference attachment and the motion attachment. So I'm going to pick just these 4 surfaces for that one, and choose coordinate system 3, and I'm going to choose these 4 surfaces. Come on. And choose coordinate system 4. So that's going to make a universal joint for us. What we're also going to do, though, is we're going to put a couple of revolute joints on here. And we're going to have them revolute be to ground, and we're just going to pick a surface for each one of them. So we're going to use this top surface. And again, this is going to auto-generate a coordinate system for us at the top, which is very, very helpful. And then I'm just going to do something very similar down at the bottom. Again, to ground, surfaces, select the surface, say OK, automatically generate my coordinate system, and we're all set. One last thing we're going to do is we're going to put a load on this. We're going to go Model, Load, Kinematic Driver. So we're going to put an enforced rotation of 7 radians just on this top revolute joint. Okay, so now the loads have been defined, the joints have been defined and everything. So we would run the model, and essentially what we would get at the end is a animation that's going to look like this. And basically you can see it's going through the entire range of motion. Now the other type of simulation entity that we are going to go over right now is flexible sliders. So basically I'm just going to go back to my simulation entities branch. We're going to open this one up. You can see that this one's a prismatic slider. And we have some other options defined. Basically, the slider trajectory is just any number of beam elements in a list. So there's just 100 beams down this track. So we're just going to say OK. Then, of course, if we ran this analysis and we animated the study, you can see that it just cruises right down that track. Back to you, Mark.
SimCenter Femap now has support for aeroelastic dynamic, frequency, transient, and random response, in addition to its long-standing support for static aeroelasticity and aeroelastic flutter. These capabilities are powered by the integrated SimCenter Nastran solver and are compatible with other versions of Nastran.
Okay, so the last thing we're going to talk about in today's session is the support for solution 146 for SimCenter Nastran and MSC Nastran. The one pre-processing thing we did to support this is you can now make an aerodynamic body load using model load body. So you can just come in here in the aerodynamic section. It's always going to be a vertical gust load. You just click define, and that's where you would enter your gust load values. Just going to come out of here, and but the big difference is in the model, in the analysis set manager, which we're going to access via model analysis. We're just going to say we want to make a new analysis set. We've added 3 new analysis types, which are aeroelastic frequency response, aeroelastic transient response, and aeroelastic random response. We're going to make a random response just because it has the most new things to show. The first thing that you're going to notice is that you now get the standard Nastran dynamic analysis dialog to come up. This is where you can enter all the values you need to run either a modal transient or a modal frequency analysis. And in this case, the modal frequency would also be what you would be using always for random analysis with solution 146. So again, just your options for dynamic analysis and solution frequencies that you might want to include. We're just going to kind of come next. A few dialog boxes here till we get to where you define your PSD or power spectral density factors. What we've added here is the ability to specify a gust PSD input instead of tabular PSD input. This is pretty typical for someone running a random response with solution 146. And the other new things that you can enter is in the Nastran aerodynamic data dialog box, which are Mach number, dynamic pressure, and whether you're going to compute or not compute your gust load. And these 3 options are available for all 3 new analysis types. So I'm just going to say OK, cancel, hit done. And what's nice about this is that you can actually then just take a look at your transient results when you animate the study, and you can kind of see the whole thing shaking nicely. And that's it, Mark.
Thanks, Andy. What you've seen here are some key enhancements that are available in SimCenter Femap 2022. I think it's one of our most exciting releases yet, but don't take my word for it. The software is ready for you to experience. If you're an existing customer, you can download the latest version of Femap from the Siemens Support Center. Now we'd like to introduce you to another Siemens customer, Pagnotta Engineering Incorporated. Founded in 1995 by Michael Pagnotta, Pagnotta Engineering is a space, flight, and aircraft hardware consulting company that provides mechanical design and analytical services to leading aerospace organizations, including Lockheed Martin, Boeing, and NASA. As a member of our early access beta program, Pagnotta has had the opportunity to see everything that's new in SimCenter Femap 2022. Let's hear what they think about the release so far.
Hi, my name is Andy Din. I work for Pagnotta Engineering. We're based out of Exton, Pennsylvania. We do structural analysis and mechanical design. I've been using Femap for about 11 years now, and some of the new features that are coming out with Femap 2022.2 that are going to be useful for our day-to-day operations are one, the laminate features. Whenever our customers express interest in moving to composites and investigating composites, a large part of that is going to involve design optimization and weight reduction, and any tools that we have at our disposal to quickly, efficiently, and accurately step through different laminate layups will be very powerful. On the solid meshing features, there's the new hex dominant meshing tools. Those are going to prove to be pretty powerful for us as well, because when working with solids, we certainly try to use hex meshing whenever possible. And the new algorithm that allows you to quickly put a hex dominant mesh onto a solid body is going to be pretty powerful. And lastly, the accelerated share features, the cloud-based sharing system. It looks promising for an organization like ours.
Thanks, Andrew. As mentioned earlier, SimCenter Femap software is now available to purchase in 2 different ways: the standalone Windows-based SimCenter Femap you've always known and loved, and our new subscription-based SimCenter ZAS offering that provides you with the benefits of cloud collaboration with accelerator share. The choice is yours. If you haven't tried SimCenter Femap yet, you can do so for free. All the new capabilities that we shared today and more are available in our trial. It's a full version of the software ready for download. Visit our website using the link below to start your trial today. We also encourage you to engage with Siemens experts and other users in the SimCenter community. The link shown here will take you to the top level of the SimCenter community, where you will find links to access our blogs, knowledge base, and discussion forums. If you have questions, type them in the chat window and we'll do our best to answer. In the meantime, I see we have a few questions already. Here's one. When using the hex dominant mesher, just how hex dominant is the mesh that is created?
I'll take that one, Mark. Essentially what we've seen is if you use the default mesh sizing, you typically get about 90% hex elements within the volume. So obviously if you take the mesh size down a little bit, you are probably going to get a higher percentage, but if you raise it, then you're probably going to get a lower percentage of hexahedral elements.
Here's another one. Obviously, Accelerator Share stores data on the cloud, but where are these actual data centers located?
I'll take that one as well, Mark. So basically, if you're in Europe, the Middle East, or Africa, the data center is located in Frankfurt, Germany. In the Americas, it's in Virginia in the United States. And if you're in Asia Pacific, it is located in Tokyo, Japan.
Okay, here's another one. Do you plan on supporting joints, those kinematic joints in Abacus?
Yes, I mean, the short answer is yes, we do, and hopefully we plan on putting that into our fall to winter release of this upcoming year.
Thank you for watching. To learn more about SimCenter Femap 2022, visit siemens.com/simcenter-femap.